All right, Newton's method part two. I'm going to do a couple quick things. Thing one, I'm going to show you when Newton's method fails. And then thing two, I'm going to show you a process that will allow you to speed this up. Now, I'll do that in the context of a new example. So let's start with when does it fail? Well, thing one, of course, it will fail. Let's just call this failure points. If your derivative is equal to 0. Obviously, your equation is divide by f prime of x. If your derivative is equal to 0, what do you want to do? Just choose a new point. Choose a new point and for your initial value and see what happens. Thing two, your approximations oscillate. You run into an oscillation. So let me show you graphically a picture. So I've got some function here, and I choose my initial value, x sub 0, and there is my x sub 1. And so I come down here and I calculate x sub 2. And you can already see the problem. X sub 2 is equal to x sub 0. My values are going to just oscillate back and forth. What do you do there? Again, I would just choose a different or value of your initial. But if this is sort of symmetric, as you can see here, what you may discover is that Newton's method just isn't a very good strategy for solving this one. And three is you start too far away. And I'll show you an example here, quick graph of an example. Let's look at this. If I am looking for this root, and I start with my initial value up here, notice that x sub 1 is way over here, and it isn't necessarily, depending on where that is, I may end up getting x sub 2 down here, and I may end up focusing in on this root. So you want to make sure that the root that, or the estimate that you start with is pretty close to where your root is. Okay, so let's talk about process in the calculator. There's a few things that you need to know, and I'm talking about the TI-84 calculator line here, because this is what we mostly use. You can type in your equations, y1, y2, y3, and I'm sure you know this. But one possibility is you could put your function in here into y1. You can use Math 8 to put the derivative of the function into here, and then tell it you want the derivative of y1. And what that's going to actually look like, it's going to look like this. And you may or may not have used this before. And what you want to do when you fill this in is you're going to fill this in with the derivative, with respect to x. You're going to put a y1 right here, and you're going to do x, put in x equals x. And then on the third, you can actually then type in x minus y1 over y2. This is your Newton's approximation method. So now what do you do when you get back to the main screen of your calculator? So on the main screen of your calculator, here's what you want to do. You want to type in y sub 3 of, and type in your value of x sub 0 and hit enter. This will give you x sub 1 as your answer. Now what you do is you type in y3 of the answer and hit enter, and it will give you x sub 2. Now all you have to do is just keep hitting enter. You have to count them, keep track. But if you just keep hitting enter, 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 it will redo the last command over and over and over again using that previous answer. So you count how many times you've done it. You keep track of whether it's x0, x1, x2, x3. And you just keep hitting enter until you get an answer that's as accurate as you want. So let's look at I think maybe I won't do another example. So let's do this. I've got I found a web page here, and maybe I can just get this link right in. Let's see, will it? No, maybe I have to do it. Nope. Text box. What's going on here? Text box. Why does it want to do a sticky note instead of a text box? Oh, because I'm not typing text box. If you go to that link, you will see 6 Newton's method problems. The first one just says, find the root. They give you x sub 0, as does the second one. The second one makes it a little more complicated. It says, find the root, and it gives you an interval, making it easy for you to choose x sub 0. It also asks you for 6 decimal places. And the final 2 problems just say, find the roots. So what you're going to want to do in 3, 4, 5, and 6 is put the equation in your calculator, which you're doing anyway. Take a look at where ballpark is a root, and then go ahead and choose a reasonably close value. And when you're done with each problem, if you click on solution, it will give you the option of show all steps, start solution, work your way through it. So there are 6 problems. Go ahead and work your way through, and hopefully this has made some sense to you. Is this necessary? No. Is it helpful? Yeah, sure. There are some times when this could be a reasonable calculation. Plus, it's sort of cool. All right. Thanks for watching.